Back to another video, guys. This is all about gradients, tangents, and normals to a curve at a given point. So obviously you need to know how the equation for tangent line and for the normal line looks like, okay? So that's all about how to derive the equations in a fast way. This short video will teach you how to do that in a few minutes. All right, so let's say we have some point and we have fx. We have point A on the curve fx, and we also given two coordinates, obviously. The x coordinate, that's small a, and if you plug a value into the function, so right now, that's going to be the y coordinate of the point A. So in total, we have the point A on the curve with coordinates a and f from A. And at this given point, you need to find the equation for the tangent line and the equation for the normal line. Okay, so you need to be aware of how to do that. Let's get started. So first of all, I start from the tangent line. It's right there, and that's your function of x, and that's your point. Exactly in this point, you're looking for it. And I put the yellow color to indicate that we're looking for the tangent. Later on, we'll deal with the normal. Okay, so you know that general equation of the line should look like as mx plus c, for example, where c is the y-intercept, m is the gradient. Okay, but it's not really convenient for this, and that's why let's rewrite, just remember what m, the gradient by definition, is change in y coordinates between two given points on the line over change in x. So that's why if we rearrange that, we can say that m times x, let's say, minus x0 will be equal y minus y0. So where x0 and y0, it's one point, and let's say x and y is another random point on the line, on the tangent line, let's say with the coordinates x and y. And here's, let it be the point with coordinates x0, y0. In other words, we already have one point, given point A. So what if we plug back, instead of x0 and y0, the coordinates that we already have and we already given? So in this case, we'll get the following: x minus a, that's going to be a, x coordinate of the given point, will be equal to y minus, in this case, y0 becomes f from a, because in this point, both line and the curve fx, they share this point. So that's why, obviously, this value is going to be f from a. So that's why we can definitely plug, instead of y0, the value of the function f from a. Okay, so let's express y from there. So y from there is going to be f from a plus mx minus a. Okay, so that's an equation of the line. However, the last question is about the gradient, how to work out m. You know that by definition of what gradient at the given point A is simply a derivative f prime at the given point A. So, and at x equals a. So that's how the gradient looks like. So if you plug it here back, you'll get the definite equation of the line in the gradient intercept form. So it's going to be not the gradient intercept. I'll just give you a comparison a bit later. So general equation of the line that is tangent at a given point. All right, so you plug, instead of m, you plug f prime from a, and here is going to be x minus a. So that's the general equation of the line. How to, for example, if you need to set up the equation in the gradient intercept form, how to do that? Just simply rearrange and say, okay, so this is an equation in gradient intercept form. So I'll just highlight it quick. Okay, so that's already the equation of the line. But you want to get the equation in gradient intercept form. So, well, you need to rearrange and expand the brackets in order to say that this is going to be the gradient m times x, and the rest part plus f from a minus f prime from a times a is going to be the c coefficient. So this is the C coefficient, as you can see here. That's free coefficient, is just a number. And f prime from A, this is the gradient. So that's the gradient intercept form for your tangent line. For your tangent line, okay? So that's easily, you can do that. All right, so let's go to the normal. So what can you say about the normal? The normal is perpendicular to your tangent line and also goes through this point. So let's pretend that you know the equation of the tangent line, which is, let's go back, so f from A plus f prime. So you write in f from A plus f prime from A times x minus A. How to work out, so that's for tangent line, how to work out the equation for the normal line, which is actually perpendicular. Just remember about the properties of two lines which are perpendicular to each other. What can you say about the gradients? So you can say that the gradient for the tangent line and the gradient for the normal should be interrelated as the following. -1 over m for the normal. Okay, so that means you can express the gradient for the normal in the way back. So this is going to be the opposite 1 over m of the tangent. But you know that m of the tangent, the gradient for the tangent line, is f prime. So that's why the gradient for the normal line is going to be f prime reciprocal with a negative sign. Okay, so if you write the general equation in the same form for the normal line, you'll actually find out that it's going to be the same as f from A, because it also goes through the point A, but except for the gradient, you need to write as the following: -1 over f prime from A times x minus A. And this is going to be an equation for your normal line. Okay, so I hope you understand that. That's pretty easy. And let's go to your simple question there. All right, so what we are given, we need to find the equation of the tangent line and the normal to the curve with the equation f from x equals 3 square root of 2x. Okay, I just rewrite this function. Fx is 3 minus square root of 2x inside. At the point with x coordinates, so x coordinate is 4.5. So well, what we're going to do, we just need to set up the equation first in general way. Let be the equation for the tangent line. So in general way is going to be f from 4.5, so we just plug in the point, plus f prime from this 4.5 and x minus 4.5. So we established the equation in general form, just having reference one more time here. So that's the equation of the tangent line, okay? And what we're gonna do, we just need to calculate f prime anyway, and f from 4.5. Let's set up in a consecutive way. So we're starting from f from 4.5. If you plug there, you'll get 3 minus square root of 9, which is simply 3. So 3 minus 3 will give you 0. Okay, so that means f from 4.5 will be 0. And now let's take derivative in general way, f from x first. So let's differentiate your function. In our case, it's going to be, what I'm going to do, I'm just going to write the square root of 2 times, and I separate, so square root of 2, square root of x, and instead of square root of x, I just simply write as x to the power 1 over 2, because it's much easier. And now I apply prime, okay, so I apply differentiation. So that's why f prime from x in general way is going to be equal negative square root of 2 out of 2, and x will get the negative power, so x will be to the negative 1 over 2. If you like, you can rewrite using the surds, so that's going to be square root of 2 over 2 square root of x. Okay, so that's derivative, and now what you need to do, you need to plug 4.5. Okay, so let's plug there, and if you calculate that, you'll get minus 0.33 and 3 in the period. So that means you'll get actually 1 over 3. Because that's recurring decimal, you can convert into ordinary fraction. All right, so we've got everything, and now we can put into the equation of tangent line. So we've got negative 1 over 3 times x minus 4.5. That means we'll get negative x over 3 and plus 1.5 if you divide 4.5 by 3. Okay, so that's an equation of the tangent line. So what about the equation of the normal? It should look like the same because we are going to use all the values right now that we got for our tangent line. Well, we exactly need to swap the gradient. So the gradient is going to be reciprocal for what you have for the tangent line. So that means it's going to be 3 times x minus 4.5. And if you expand the brackets, you'll get the following. You'll get 3x, and minus, if you multiply by 3, 4.5, you'll get 13.5 definitely. So that's the equation of the normal line, and you need to make sure that they're perpendicular. If you want to have a look how it looks like, how the looks like on the graph, so that's your point. That's your point, 4.5. So this x equals 4.5, and you're looking for the tangent. So tangent line should be, so that's approximately, I'm not sure, like, this is more, about trial and errors method because you need to do it by your eye, okay? Put a tangent. So let's assume this is the tangent. And this definitely y-intercept somewhere around 1.5. You can compare with the equation. 1.5, that's y-intercept. What about the gradient? It's definitely negative and it's less steep. So it looks like negative 1 over 3. So the gradient for the tangent line is around negative 1 over 3. Okay, so done. What about the normal? You can put the line which is perpendicular to your line, okay? So that's going to be in the normal line. And if you put, if you try to estimate the y-intercept, is going to be very, very below. So definitely it's around 13.5. So that was done algebraically, and the gradient is 3, so because it's more steep. So that's the presentation for your specific function that you're given, and that's how you need to find the tangent line and normal line. Hope you like that. Hope it's pretty clear. So if you're new here, please subscribe and support me, and also check out videos related to A-level. I start from differentiation, so you can find differentiation from first principle if it's hard for you, or just several rules for differentiation. Okay, and don't forget to visit A-level Zillion's classes for more information. Thank you. That was Daniel Dallas, and peace out.